everybody. So we're trying something a little different today, and we're going to have these video notes. What we're talking about today is algebraically solving a systems of linear and quadratic functions. So we've got some steps that we'll be using to help us with this. And it's these 4 steps here. So our first step is going to be solve both equations for y. So if we look at our first example here, y equals x squared plus 5x minus 7, and y equals 3x plus 1, step 1 is already done. Both equations are already set equal to y. Step 2 says we're going to set the equations equal to each other. Now, if I'm going too fast for you, it's okay. You can pause the video and write the things that you need to. That way you can, for those of you that need more time to write, you have that ability. So step 2, you're going to set the equations equal to each other. So what that means, you're going to have x squared plus 5x minus 7 equals 3x plus 1. Okay, so those first 2 steps went by rather quickly. Step 3 is where we have the majority of our work that we need to do. Step 3, we're going to move all the terms to one side and solve for x. Now, the way we solve, we have different methods that we've talked about to solve a quadratic. We can factor. We can also take the square root of both sides. And we also have the quadratic formula. Okay, so this is where we'll be spending most of the time on these problems, is in step 3, solving for x. Really, all this is another example of solving a quadratic formula, or quadratic equation, I should say, with an additional step afterward. So here we're going to subtract 3x from both sides. We're going to subtract 1 from both sides. So what I have is x squared plus 2x minus 8 equals 0. Now I can choose any of the methods to do. I could try to factor this. I could do the quadratic formula. I could try completing the square so that I could then take the square root of both sides. But looking at this one, I can see that it easily can factor. If I'm looking for something that multiplies to give me -8 and adds to give me +2, that's going to be 4 and -2. So those are what my factors are going to be. X plus 4, x minus 2 equals 0. So to solve it for x, I set each of these equal to 0. X plus 4 equals 0. So I subtract 4 from both sides, and I get x equals -4. For the other factor of x minus 2, I say x minus 2 equals 0. So I add 2 to both sides, and I get x equals +2. So there's the third step, moving everything over and solving it for x. The additional thing that we have to do now is, once we have found our x values, we need to plug those x values back into one of the equations, which typically we'll want to use the linear equation because it's less work that we have to do with it. So we'll plug it back into that linear equation. That way we can solve for y. So I've got y equals 3x plus 1, so 3 times -4 plus 1. 3 times -4 is -12. -12 plus 1, y of negative 11. Just like when we were writing our solutions to previous systems of equations, our answers are ordered pairs. So it's going to be the point where they intersect, and it's the point x, y. So it is the point for this one, negative 4, negative 11. But I also have this other point. I must do both of them. So I have the other x possibility of positive 2. So I say y equals 3 times 2 plus 1. 3 times 2 is 6. 6 plus 1 is 7. So I've got y of 7. So the other solution is the point 2, 7. Okay, so we're gonna, again, follow these same steps and look one more time, looking at example 2. Example 2, I have y equals 4x minus 3. I have y equals x minus 1 quantity squared. So here, again, they are both already set equal to y, so I can just set them equal to each other. So I've got x minus 1 squared equals 4x minus 3. So I'm going to move all the terms over to the left side. So I'm going to subtract 4x from both sides and add 3. So I get x minus 1 all squared minus 4x plus 3 equals 0. X minus 1 squared, if I were to FOIL that out, that's going to give me x squared minus 2x plus 1. So then I have minus 4x plus 3 equals 0. Combine my like terms. I have x squared minus 6x plus 4 equals 0. Now here, again, I could try factoring. I could try completing the square to take the square root of both sides. What I want to do on this one, I'm looking at it and I know it's not going to factor, so I'm going to choose to do and use the quadratic formula here. So if we remember the quadratic formula, we've got negative b plus or minus the square root of b squared minus 4ac, all of that being divided by 2a. So we need to identify our a, b, and c values and just put those in their corresponding spots in there. So my a value comes from my x squared term, so a is 1. My b value comes from the x term, so b is negative 6. And my c value comes from my constant, so c is 4. So I can go plugging these values in. So I've got negative 6 plus or minus the square root of negative 6 squared minus 4 times 1 times 4, all divided by 2 times 1. So that's just taking the quadratic formula and putting those values in their proper locations. So now let me just, and this is what, that's going to give me my x values. So here, the negative 6, that's going to be 6 plus or minus the square root Negative 6 squared is 36, minus 4 times 1 times 4 is 16, all over 2. So I have some more simplifying to do. I've got 36 minus 16 is going to be the square root of 20. So I've got 6 plus or minus the square root of 20 divided by 2. The square root of 20 can further simplify. The square root of 20 is the same as saying the square root of 4 times the square root of 5. And we know that the square root of 4 is 2. The square root of 20 is 2 square root of 5. So what I've got is x equals 6 plus or minus 2 square root of 5, all divided by 2. And both the 6 and that 2 are divisible by 2. So when I divide these out, remember, if I can, I divide both of them to simplify that all the way. So I've got my two x's are going to be x equals 3 plus the square root of 5, because 6 divided by 2 gives me that 3. 2 divided by 2 gives me just the 1 in front of that square root of 5. So we've got x equals 3 plus the square root of 5. And on the flip side, if I do the or minus, it's x equals 3 minus the square root of 5. So that gives me my x values that now I need to plug back in to one of my equations. And I'm going to choose, again, the linear one. So I have y equals 4x minus 3. So I've got y equals 4 times this x value of 3 plus the square root of 5, and then minus 3. When I am multiplying this, that 4 distributes to both parts here. So this becomes y equals 4 times 3 is 12, plus when I multiply by the radical, it doesn't multiply to the number underneath it, it just multiplies in front, so it is plus 4 square root of 5. And I still have the minus 3. So I combine my like terms and I have y equals 9 plus 4 square root of 5. So for that first, for this one, I have a solution point, an intersect point of 3 plus the square root of 5, 9 plus 4 square root of 5. That's one of my intersections. I do it again with my other x value. Remembering to do it for both the x values that I had. So y equals 4, 3 minus the square root of 5 minus 3. So again, I distribute that 4. So I have y equals 12 minus 4 square root of 5 minus 3. Again, because I distribute that 4 goes to the 3, and the 4 goes to the square root of 5. So I've got this here. And I subtract the 3 from the 12. So I have y equals 9 minus 4 square root of 5. So I have another ordered pair here of 3 minus the square root of 5, 9 minus 4 square root of 5. So our third example that we're going to look at, we have y minus 3x equals 2x squared plus 7. The other one with it is 1/3 y equals x minus 3. So for this one, we do have to do that first step. We need to solve both of the equations for y. This first one, I just add 3x to both sides. So I get y equals 2x squared plus 3x plus 7. And here, where I have 1/3 y, that's really the same thing as saying y divided by 3. So in order to get rid of that, what I need to do is I need to multiply both sides of the equation by 3. So if I multiply all of this by 3 and all of that by 3, that 3 times 1/3 goes away, and I end up with y equals, on this side, I distribute that 3. So I've got 3x minus 9. So now I can set these equations equal to each other. So I have 2x squared plus 3x plus 7 equals 3x minus 9. So now is where I'm at step 3, to move all the terms over to one side and then solve for x. So I'm going to subtract 3x from both sides. And I'm going to add 9 to both sides. So I end here with 2x squared. 3x minus 3x, those cancel. So I have 7 plus 9 is going to be plus 16 equals 0. Now this, I don't have any just x's to deal with, so this one I could very easily solve just for x squared and take the square root, do the square root method. So I'm going to subtract 16 from both sides. So I have 2x squared equals negative 16. And then to get that x squared alone, because right now it's being multiplied by the 2, so I need to divide both sides by 2. And I have x squared equals negative 8. So I can take the square root of both sides. And I get x equals positive or negative square root of negative 8. Square root of negative 8, I want to get rid of that negative, so it is the square root of 8 times the square root of negative 1. And the square root of 8, that's the same thing as saying the square root of 4 times the square root of 2. So that ends being x equals positive or negative. The square root of 4 is 2. The square root of negative 1 is I. And then I'm left with the square root of 2. Now, here is something important to note. If, when you solve for x, you have an imaginary number, you can stop right there. This has no real solutions. If if we saw this graphically, we would have our parabola, and then the other line would miss it entirely. The two never cross. This is a no solution situation. So if, when you solve for x, you have the imaginary number, that is what tells you there are no real solutions, and that's all you need to do. So the big takeaways here are really just, solve it for y, get it equal to each other. Once you've solved for x, you have done near all of the hard work for this. Plug that value back in to the linear function, whichever one is going to be simpler, to get the y value, and make sure that you put your answers as ordered pairs and put both of those solutions. Okay.